Peru is located on the western coast of South America, bordered by Chile, Bolivia, Brazil, Ecuador, and Colombia. More than half of Peru consists of jungles and forests. Consequently, over half of the 30 million people in Peru live along the coast, while others live in the Andes Mountains. Earthquakes are a familiar occurrence in Peru. In fact, Peru lies on the Peru-Chile Trench, one of the most active tectonic boundaries in the world. The deadliest earthquake occurred in May 1970 in northern Peru. This magnitude 7.9 earthquake resulted in some 70,000 deaths. The 2007 Pisco earthquake was one of the largest shallow earthquakes that has taken place in central Peru in over 250 years. It occurred on August 15, 2007, with a magnitude 8.0. Its epicenter was located offshore, about 60 kilometers west of the city of Pisco, for which the earthquake is named, and 150 kilometers south of the capital of Lima. Numerous aftershocks followed for weeks after the main shock. The earthquake occurred on an active fault where the oceanic Nazca Plate is steadily pushed beneath western South America, including Peru. We call this process oceanic subduction. With time, stress builds up on the fault until it is suddenly released in an earthquake. Subduction zone earthquakes often also cause a tsunami due to the uplift of the seafloor near the fault. The earthquake consisted of two separate ground-shaking events, separated by about 100 seconds and lasting about 3 minutes total. Thus, the most noteworthy characteristic of this earthquake was the long duration of shaking.
Sur a norte, claro, así. Pero el siguiente que ya comenzó ya fue hacia
todo
sentido.
Muy fuerte. Demasiado, saltaba.
Seguía así temblando todavía. Todavía seguía temblando. Todavía.
Maximum intensities of ground shaking, as indicated by orange, were in the cities of Pisco, Ica, and Chincha Alta. Therefore, the majority of casualties and damage occurred in these regions. The Pisco earthquake occurred at around 6:40 in the evening, a fortunate time as many people were out and about on the streets, thereby limiting the number of casualties. There were about 500 deaths and over 1,000 injured. About 10 to 20 minutes after the earthquake, a large tsunami, around 4 to 5 meters high, inundated the coast of the Paracas Peninsula. Many people did not get warnings for this tsunami or were even aware of the potential hazard. Several people died as a result. In addition to a tsunami, the earthquake also caused major landslides and liquefaction. As a result, many roads were damaged, power lines fell over, and underground pipes broke. More extreme, however, was the number of homes damaged or destroyed. Adobe housing is the main type of structure in Peru. It has been a traditional construction method and is the cheapest and most affordable for many Peruvians. Adobe structures are highly vulnerable to earthquakes. For example, in Pisco, more than 80% of the adobe houses collapsed or sustained heavy damage. In total, more than 35,000 buildings collapsed and some 4,200 buildings were damaged, leaving more than 100,000 Peruvians homeless. Adobe consists of 50% sand, 35% clay, and about 15% straw. These materials are mixed together with water. After they are put into a brick mold, the bricks are left to dry for several days. When used for construction, the bricks get stacked one on top of another, and then they are covered with plaster. Adobe structures are not safe in seismically active areas because they are very heavy and have very low strength. The level of damage sustained by adobe houses in Pisco, Peru, is a vivid example of their high vulnerability. The Pisco earthquake is a reminder of the importance of building earthquake-safe structures. Since adobe is a very economical building material, It's important that techniques be adopted that will strengthen and reinforce adobe structures. The most important factor is reinforcement to keep the walls from collapsing and to provide stability during an earthquake. One new, easy, and affordable method discovered by a Peruvian engineer, Marcial Blondet, is reinforcement of the walls with an industrial plastic mesh that will prevent walls from collapsing in an earthquake. Other techniques include using compact box-type layout, or building just a one-story building, and building on a more firm foundation. Also, the quality of workmanship is always critical in successful construction of earthquake-resistant adobe structures. If adobe homes are more properly constructed and reinforced, the number of casualties and damage from an earthquake in a country like Peru can be significantly reduced. Therefore, it's important that adobe structures in seismically active areas be made highly earthquake resistant.